Welcome to Chemistry Not Mystery. In this video, I am going to discuss valence bond theory and its limitations. This video is also available in Hindi and you can get its link in the description box. According to valence bond theory, covalent bond is formed when half-filled valence orbital of one atom overlap with the half-filled orbital of the another atom. Electrons in half-filled orbitals must have opposite spin so that they can neutralize each other. Number of bonds formed will be equal to the number of half-filled orbitals, or you can say it is equal to the number of unpaired electrons. When two atoms approaches each other, initially they attract each other, but when they come closer, their valence electrons repel each other. But at a certain distance, repulsive forces balance the attractive forces. And at this equilibrium distance, these two atoms attain the minimum energy and reaches to the maximum stability. So at this equilibrium distance, the distance between two nuclei is called as bond length. Greater the extent of overlap, stronger is the bond formed, though there is not complete overlap take place. According to valence bond theory, paired electrons present in valence shell cannot participate in the bonding. During the bond formation, s orbital can overlap in any direction because it is spherical in shape, while p orbitals can overlap only in x, y and z direction. Similarly, d and f orbitals also can overlap in only certain directions. Thus, covalent bonds are directional in nature. When px orbital and s orbital overlap, they overlap along the internuclear axis and it results in the formation of sigma bond. This bond is known as px-s sigma bond. This type of overlap is also known as head-on overlapping. Similarly, when px and px orbital overlap, they also overlap along the internuclear axis and they form px-px sigma bond. Whenever sigma bond is formed, it is always formed by the head-on overlapping. When py and py orbitals overlap, they overlap perpendicular to the internuclear axis. This is the internuclear axis and y-axis is perpendicular to this internuclear axis. And it results in the formation of py-py pi bond. So whenever pi bond is formed, it is formed by the sidewise overlapping. Similarly, when pz and pz orbital overlap, they overlap perpendicular to the internuclear axis and it also results in the formation of pi bond. So when you compare the strength of sigma bond and pi bond, the strength of bond depends on the extent of overlap. In sigma bond there is better overlap. That's why sigma bond is stronger than the pi bond. VBT has certain limitations. For example, it couldn't explain the shape of water molecule. According to VBT, orbitals of the central atom decide the shape of the molecule. In water, the central atom is oxygen. And according to VBT, half-filled valence orbital should participate in the bonding. That means this py and this pz will participate in the bonding. And these two orbitals are perpendicular to each other. So the shape of the water molecule should be right angle and the bond angle should be 90 degree. But in reality, the water molecule is bent in shape and the bond angle is 104 degree 45 minutes. This couldn't be explained by the VBT. Similarly, VBT couldn't explain the shape of methane molecule. In methane, the central atom is carbon and this is the ground state configuration. When you write the excited state configuration, you will get 1s2, 2s1, 2p3. Thus, you will get 4 half-filled orbitals. These 4 half-filled orbitals should participate in the bonding. And these orbitals are going to decide the shape of the methane molecule. But these orbitals are right angled to each other. This is px, this is py, and this is pz. All these orbitals are right angled to each other. So the shape of methane molecule can't be tetrahedral. That is the actual shape of the methane molecule. And this couldn't be explained by the VBT. Thanks for watching, but don't forget to like and share this video. And if you have any doubt, you can post them in the comment box. You can also subscribe to my channel and press the bell icon to get a notification. You can also join my Telegram channel or follow me on Twitter or Instagram.